Hello everyone. First, I will give you a brief idea about what you will learn through this series of short lectures. Through these videos, you will learn about electronic devices like diodes, VGTs, MOSFETs, and their implementation in the circuit. In the few initial lectures, we will be covering various topics from other domains like quantum mechanics, material science, nuclear physics, etc. These topics together constitute the basics of semiconductor physics, and as we move forward through these lectures, we will be focusing more and more core topics of the subject. Without wasting any time, we move to our first topic: force on a charged particle. The force F on a positive charge Q in an electric field of intensity E is given by QE, and the resulting force will be in the direction of the electric field. We can write force is equal to QE. We also know that work done W is equal to integration of force F with respect to distance x. And we know that force is equal to QE, therefore we can write work done W is equal to integration of QE with respect to distance x. Now we will consider an electron whose charge is equal to minus Q, and also we know that electric field is equal to minus differential of potential V with respect to distance x. Now if we put these values in the equation of work, then we will get charge will be substituted with minus Q. Electric field can be written as minus dV over dx multiplied by dx. This dx will cancel, 2 minus n will cancel each other and will result into a positive sign. Therefore, the final expression we have is W is equal to integral of Q with respect to potential. Since charge Q is an constant, therefore we have work done is equal to Q into VAV, where VAV is the potential difference between the two reference points of integration, which are A and B. Very commonly used unit of work or energy in the study of semiconductor is electron volt. 1 electron volt is equal to the charge on an electron, which is 1.6 into 10 raised to the power minus 19 coulomb multiplied by 1 volt. And 1 coulomb into 1 volt is equal to 1 joule. Therefore, 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. This is the energy which is required for an electron to move across a potential barrier of 1 volt. Now try to solve a question on your own. The total time given is 1 minute and 30 seconds. Now I am solving the question. You can cross check your answer. Electric field is provided 3x square plus 7x plus 4. And we know that electric field is equal to negative of differentiation of potential with respect to distance x. Now putting the value of electric field and integrating, we will get the expression for potential. Here a is the constant of integration. We are provided that at x is equal to 2, potential is equal to 59. By putting the value of x and v, we can find the value of constant of integration a. We will get the value of a to be equal to 89. Therefore, potential is equal to now we have to find the value of potential V at x is equal to 1. Therefore, at x is equal to 1, potential will be equal to, by putting the value of x equal to 1, we find the value of potential equal to 80.5, which is our final answer.